Okay, so in this short segment, we're going to describe something called the standard deviation. So standard deviation. So the standard deviation is a means in which we can describe data and we can describe how it deviates from its average. So let's kind of make this a little bit more sensible. If we have a data set xi, and we think of this, xi is a subscript, and I don't want to go talk about too much about this, but this is something called a vector. So think of it as a list of data. So if we want to say how all of these points in this list deviate from the average data, well, we can think of it like that. So for example, if we had a straight line like this was our mean, and we wanted to find out how these points deviated around it, all we would do is subtract these from the mean. Okay, so this is our first point. However, we've got a sticky situation here because we might have a negative value. So say we have x, this is time or quantity. We might then have a value where standard deviation changes for negative time. Well, according to Newton or according to Einstein, we can't have negative time. Well, not simply anyway. So we can't have that as a negative vector. So what we do is we square this value, and that gives us then the square of these values, and that gives us then a positive value always. So we then want to kind of average these values. So we found the deviations, and if we were to find the average like we did previously, like this, and divide it by n, we now have a description of the average square values. Square rooting it gives us our deviation, our average deviation from the mean. So what you might have noticed here is we can actually tidy this up a little bit as well. We could say that if we have an x here, this could go outside of these brackets. Therefore, we would have something that looks a little bit like this. And if we square root all of this, we now have an equation which is simpler than this equation. In the exam, however, I only give you this equation and I don't give you this equation. So you'll see as we go and do the calculation now which one's quicker when we do a quick example. If you can, remember this second one. It's in the textbook if you've forgotten it or you've not followed this lecture, but that's going to help you out potentially if there is one of these questions in the exam. So let's take the data set we had previously, and what we're going to do is we need to first of all take the equation which we have here, and to calculate the standard deviation we need to say, well, we have 120 squared plus 150 squared plus 180 squared plus 130 squared plus 130 squared plus 160 squared plus 180 squared plus 140 squared plus 150 squared plus 170 squared plus 200 squared plus 170 squared. So what we have now is we have the total we have of all these data. We can divide all of those by n, which is by 12, or 12 pieces of data, and then we want to subtract from this the mean value squared. So we'll just write this a little bit neater. We'll get some numbers on. So the equation says we have the square root of 301,000. No, it's not that many O's. We're missing an O. That's it. Divide by 12 minus 155.67 squared. We worked this out earlier. And we stick that into the calculator, and we'll actually find our standard deviation is 29.52 grams per meter cubed. This is a really, really interesting piece of information, and this can really show you some features in your data which you might not have seen previously when you've just used some standard statistical tools like your p-value or your t-test. Okay, so that's the standard deviation. We're now going to look at how we can group data to make it more simple.